Since we are looking for the solutions of the nonlinear equations, we need to draw their graph on the same coordinate plane. Thus, describe the first graph to visualize points x and y that satisfy simultaneously both equations. We look at the intersection of the zero curves of the functions f and g as illustrated on the second graph. The second curves of the zero curves of the functions f and g intersect at 4 points, each of which corresponds to a solution of the system. For example, there is a solution near positive 1 and negative 1. By using the Newton's method, we now have f of x and y is identical to x squared plus 4y squared minus 9 equals 0. By applying the power formula, f sub x of x and y is equal to 2x, and then f sub y of x and y is equal to 8y. And since in the previous graph, we have the solution that is approximate to 1 and negative 1, so at x sub 0 equals y sub 0, it is equal to 1 and negative 1. So f of x sub 0, y sub 0 is equal to f of 1 negative 1, which is equal to 1 squared plus 4 negative 1 squared minus 9 equals negative 4 by substitution method. And f sub x of x sub 0, y sub 0 is equal to 2 times 1, which is equal to 2. And then f sub y of x sub 0, y sub 0 is equal to 8 times negative 1 equals 8, again by substitution method. The tangent plane at x sub 0, y sub 0, f of x sub 0, y sub 0 is equal to 1, negative 1, and negative 4 of the surface of z equals f of x and y has the equation z is equal to p of x and y that is identical to f of x sub 0, y sub 0 plus x minus x sub 0, f sub x of x sub 0, y sub 0 plus y minus y sub 0, f sub y of x sub 0, y sub 0. And applying or substituting the values that we had solved earlier in the previous discussion and substituting it to the formula that was given here, the result is equal to z is equal to p of x and y, and it is identical to 2x plus 8y plus 2. Using the Newton's method, we have the second equation, g of x and y is identical to 18y minus 14x squared plus 45 equals 0. And then again, applying the power formula, we've got x or g sub x of x and y equals negative 14 multiplied by 2 equals negative 28, and then x. Since we subtract 2 and then minus 1, that will be x. And then g sub y of x and y is equal to 18 because the exponent of y is 1, so we multiply it by 18, that result is 18. And then the solution of the graph that we have is approximately 1 and negative 1. So we use that at x sub 0 equals y sub 0. And then again, applying the substitution method, g of x sub 0, y sub 0 is equal to 18y minus 14x squared plus 45. So we substituted the values of 1 and negative 1 for the x and y variables, which resulted to positive 13. And then g sub x of x sub 0, y sub 0 is equal to negative 28x. So substituting the value of x, which is positive 1, the result is negative 28. And likewise, g sub y of x sub 0, y sub 0 is equal to positive 18. And since we don't have a variable there, the result is still positive 18. The tangent plane at x sub 0, y sub 0, f of x sub 0, y sub 0 is equal to 1, negative 1, and 13 of the surface of Q equals g of x and y, and has the equation Q equals P of x and y, which is identical to g of x sub 0, y sub 0 plus x minus x sub 0, g sub x of x sub 0, y sub 0 plus y minus y sub 0, g sub y of x sub 0, y sub 0. And again, using the values that we had solved earlier, and then substituting it to the formula here that we have, q is equal to p of x and y, which is identical to negative 28x plus 18y plus 59. That ends our report. And we are the group 3, having the members Bernadette Badet Campanel, Feliciano Joey Landicho III, Romel Mel Soriano, Rosenda Rose Villaruel, and yours truly, Anin Lynn Rosendal. Thank you very much, and God bless.